Welcome to Season 2 of Maker Club by EE Focus in partnership with the Hackaday Prize, a world-renowned hardware design contest, and Digi-Key Electronics, a leader of distribution of electronic components. As our long-term partner, Digi-Key Electronics would like to work with electronic engineers around the world to create and change life with technology constantly. Let's discover the splendidness created by makers together. In this episode, we sit down with Ken Endo, a mechanical prosthetic engineer in Japan, to discuss the topic of mechanical prosthetic.
I am Ken Endo, engineer who is making the prosthesis for athlete and the amputee.
Could you share what initially drove your research switch to mechanical prosthetics? And what are the reasons behind your ongoing and further researches in this field?
When I was a college student, I was studying the robotics, mainly the biped humanoid robots. And a cancer was found at my friend's knee joint, and he was amputated after that. And that's why at that time, I really wanted to make a leg for him using the robotic technology. And that is my reason why I started to study the prosthesis technology.
In your biography, we noticed you acted as an instructor of MIT lab course for developing countries and focused on the development and wider adoption of mechanical prosthetics. Why did you put greater focus on developing countries? And could you name a few of them of your concern?
So I'm mainly making the prosthesis for the country where the insurance systems are there. But in the developing country, almost no country has the insurance system like a developing country. So the cost is very, very important. When I was studying the prosthesis technology, that is mainly for the developing country, which is very expensive. And the many people in developing country cannot afford to purchase that prosthesis technology. So they are making a very affordable one using the material they can get from the local market.
Could you talk about how big the gap in mechanical prosthetics is between developed and developing countries? What are the specific aspects of such a gap? In your eyes, what are the key aspects that developing countries need to play catch-up? Or, what are the challenges facing developing countries in the wider adoption of mechanical prosthetics?
Usually, in a developed country, we have the insurance system which can cover the cost of the prosthesis. And in the developing country, there is no insurance coverage for people. And that's why the cost of the prosthesis is too expensive for developing country. And in that kind of country, they need to make a prosthesis technology using the very affordable material they can get in the local market.
Is users' comfort or higher flexibility of manipulation the foremost consideration in developing mechanical prostheses?
It's highly depends on the user's function. And that mainly the remaining function is very important to control the prosthesis. So in my opinion, it's very important to consider the balance between the flexibility and comfort as well as the safety.
Mechanical arms need to provide certain load-carrying capacity, in addition to the flexibility of manipulation. When it comes to mechanical legs, do they need to provide a load-bearing capability? Besides the flexibility of manipulation, what are the other functions that may be easily overlooked?
It's also important for prosthesis to have the power to support the body weight. It's because the amputee have a risk to fall down on the ground, and the prosthesis try to avoid that situation. So the power to support the body is very important for the leg prosthesis as well.
We noticed that you have developed a sensor for mechanical prosthetics. What are the functions and properties of mechanical prosthetics that the sensor can help improve? Why did you want to develop a sensor instead of using existing products in the market? Could you talk about the R&D journey of the sensor? What were the difficulties? Is that sensor still be used? Or has it been updated or upgraded?
In the process of development of the prosthesis, we invented a very lightweight torque sensor to drive the prosthesis. It was very important because we need to carry that prosthesis anywhere, and so user needs to carry that weight. So lightweight is very important to walk on the ground safely and comfortably. So we needed to make a light one because there's no such a lightweight in the market.
The appearance of current mechanical prostheses seems to be moving away from emulation of natural limbs and takes on a more visible cyberpunk style. Is this a sign of progress?
I think it highly depends on the preference of the users. So in my opinion, I like the mechanical design of the prosthesis rather than the natural appearance leg. So that's why we designed the prosthesis such that looks cool by showing the mechanical structure of the prosthesis.
On the way to upgrading mechanical legs, what is the most difficult technology to break through at present?
I think the most difficult things to make a prosthesis is to make the device lighter as much as possible by keeping the functionality. So mainly, human can do anything. Human can walk, run, and jump. And if you want to make something which can do everything, it tends to be very heavy. So we want to make it, but the space and the weight is very limited. So we are always trying to make the functionality more and more by keeping it lighter.
Will mechanical prostheses suddenly go wrong? Such as power failure, short circuit, or other failures? How do they maintain their power supply?
So mechanical failure and circuit failure always happen during the process of the development. And we are always making fail-safe on the software and hardware. And we are always trying to keep it safe for the empty.
Can mechanical prostheses as electronic products walk in water? What are the other life applications where the users of mechanical prostheses still face big difficulty?
So currently, the prosthesis we are now making is not for the water walking because the prosthesis is not covered by anything. But the human always work on the various type of the surface with the water. So definitely we want to, in the future, make it waterproof.
The mechanical prostheses needed by the average persons with disabilities and the disabled athletes look different. The athletic prostheses look more simplified and are in L shape. Is this designed to adapt to the jumping ability of athletes?
Human can do anything. Human can walk, run, and jump, as I told you before, and prosthesis needs to be functional. But if you want to focus on one function, such as the running, the mechanical structure can be also simpler. So the running prosthesis made by the carbon fiber is very simple. So the running prosthesis is very simple just because we focus on the running function.
The current mechanical prostheses are controlled by electrical muscle signals. When do you expect that mechanical prostheses can be controlled by brain? Will the brain-computer interface, BCI, technology enable such a brain control?
So human can do various type of the motion. So for the involuntary motion, the brain signal from the brain is very important to control the leg. But for the involuntary motion, such as walking and running, and the brain signal is not necessarily needed to control it. So it highly depends on the motion that we can pick the signal from the nerve, brain, and muscle.
You mentioned that a remark by Professor Hugh Hare from MIT, "The barrier is not in people, but in technology," touched you deeply. Ideally, what life or sports scenarios do you see technology will help the disabled achieve in the future?
I also think that technology is one of the key to change the game. Human is disabled just because we don't have any technology to compensate the loss of function. If we have a perfect technology which can compensate the loss of function in the future, no one can be disabled.